Alright, I'm going to draw out how this works in my head here. So we're going to take a voltage source right here. We'll grab a voltage source, two resistors, ground, and 3 voltmeters just to show the three different connections. So here's my voltage source. I'm going to make it let's make it 10 volts so we can see, so we'll be able to divide the circuit and let me keep it at 1 kilohertz. So let's do this. So these resistors, I would think for this to work by connecting the scope to battery ground and getting a half amplitude signal, the only way I could see it working, and this all comes from me trying to being cautious of connecting my scope to ignition coil or whatever, along with a crank position or cam sensor. So this is the crank sensor, let's call it. I think these resistors or some type of solid state electronic in the ECM. I'm not an electronics guy, but I think these would be in the ECM, and this is battery ground. So so the resistors are the only thing in the ECM. So let's wire them up. And we'll wire that to ground. And now I'll take a 1 voltmeter and we will connect it, let's call it to crank position positive, and let's connect the other side to battery ground. Okay. Let's take the other side and let's call it, let's connect it to battery crank position negative, and we'll connect the other side to battery ground. Then let's take another voltmeter and let's connect it from crank position positive, or connect it to crank position positive and crank position negative. So there's your 3 different connections. Again, the only thing in the ECM is this circle right here, and I think they do connect to the ground. I think that wire does connect to ground. So let's run a simulation, and the first voltage we'll look at is just the regular connecting to crank position positive and battery ground, and we will watch that on the voltmeter. On the left is voltage right here. So you can see we get a 5 volt, and remember we're starting with a 10 volt voltage source. So there's that. There's the 5 volts in one direction. Let me bring this down. So now let's read the other side connecting negative to battery ground, and we'll read that. And that gives us your mirrored signal at 5 volts, half the amplitude. And then if we were to read the crank, so we connect, now we're connecting our scope to the crank position positive and negative, and if we were to read that, that would be the full amplitude signal. As you can see, it's your 10 volts right there. Without, if you look at my mouse, without so say you come out of your crank position, into your scope, out of your scope, you need to get back to the other wire, the second wire of the crank position. You need a full circuit. So I think there is a ground. I think they are connected to ground through a resistor. It's the only way I can make it work in my head. Admittedly, I'm not an electronics guy. I do have some, knowledge of circuit flow, and this is the only way I can come up with it. To me, it's almost like an electrical service, 240, and how you can read 120 from line to neutral. You'd almost get the same readings. being 240 and then 120 on each. But the 120, the single phase or the single leg voltage to neutral would be opposite. Um, again, uh, if anyone can advise me different, but this is how I've made it work out in my head. So do appreciate all the help I get on here. Learn a lot from everyone on the Telegram app here and the whole H-Scope community. Have a good weekend.